Today's lesson is about powers of 10. We're going to learn how to use a power with a base 10 and an exponent that could be really large or really small to write numbers, and how to calculate those numbers without doing a lot of multiplication. Let's get started. All right, so why is this important? Powers of 10 are important because they help scientists and mathematicians that work with really large and really small numbers write them in a condensed space. So what I mean by that is if you're an astronomer and you're trying to calculate the distance between the Earth and the Sun, that's a really large number. So powers of 10 help us to write those numbers in a smaller form, and it takes up less space, so it's easier to talk about the numbers and write them down. And so we're going to learn how to use a method next class that incorporates powers of 10 to do that. Same thing with scientists that look under microscopes for a living. They're looking at single-cell organisms and really small, lightweight living things that have weights that are 0.00, lots of zeros. So the weight is really small, but the number that you would write to get that small weight is long because of all the 0.0 after it. So again, powers of 10 helps to make that space a little bit less to write in. Okay. So some examples of powers of 10. Here's the first one. You should know how to solve this from the exponents lesson. 10 to the second power means 10 times 10, and 10 times 10 is 100. 10 to the fifth power might take you a little bit longer to solve because you have to do 10 times 10 times 10 times 10 times 10. If you solve that, though, you would get 100,000 as your answer. So take a look at those two problems. What can you tell me about the exponential form and the standard form of each of those? So what do you notice that might make this easier to solve instead of having to write out 10 times 10 times 10 times 10 times 10 and solve it? What might you notice? Okay, well here's what you should notice. The value of the exponent is equal to the number of zeros in the answer in standard form. So 10 to the second power has an exponent of 2, there's 2 zeros. 10 to the fifth power has an exponent of 5, there's 5 zeros. This little shortcut or trick works when you have a base 10 with a positive exponent. So if you saw a number that was negative as your exponent, you couldn't just do this to get the answer. If you saw a power that had a different base than 10, if it was 9 or 8 or any other number, you couldn't do this. But when you have a base 10 with a positive exponent, you can use this trick to get your answer. So let's try practicing once. What would 10 to the ninth power be in standard form? So see if you can figure that out. Okay, the correct answer would be 1 billion. It would be a 1 with 9 zeros after it because the exponent is 9. So 10 to the ninth power is equal to 1 billion. All right, so hit pause, try this out. Try that with these 4 problems, see if you can get the answers, and then you can check it when you're done. Okay, here are your answers. 10 to the third power is 10 times 10 times 10, which would equal 1,000, but you can use the shortcut I just showed you. If this is a base 10 with a power of positive 3, an exponent of positive 3, you can put 3 zeros after it, okay? This one here, exponent of positive 1, 1 zero. Exponent of positive 11, 11 zeros. Exponent of 0, no zeros. And we actually learned in the exponents lesson that anything raised to the 0 power equals 1, so that it all kind of connects and makes sense. All right, so we're starting out with this. But there's some questions that you need to solve, or ask yourself. What happens if the exponent's negative and you can't do this trick? How do you solve this problem? Is the answer negative? Is the answer positive? Is it a small number, a big number? Well, I'm going to show you. All right, so here's the key concept. The key concept is when you multiply by 10 or divide by 10, that's really what we're doing. We're taking a power of 10, so we're just doing 10 times 10 times 10 a bunch of times. Or in some cases, we'll be dividing, and I'll show you that in a second. The decimal point can be moved one space every time you multiply by 10 or divide by 10. All right, so here's how that works. If you have a negative exponent, like these 2 problems here, you can look at the exponent, and that tells you, since it's negative, that you're going to move left, because this negative exponent kind of implies that you're dividing by 10 or multiplying by a tenth. So it's going to move the decimal point to the left when we go to calculate our answer. And I'm going to show you how the shortcut earlier kind of ties into this right for multiplication down at the bottom here, because when you see a positive exponent, like in the first 2 problems I showed you at the beginning of this lesson, you can move the decimal point right to get your answer. because positive exponents means the answer is going to get bigger. Negative exponents means the answer is going to get smaller. It does not mean you're going to have a negative answer. It means you're going to have a small answer. All right? So let's look at the answers here. Example 1, 10 to the negative second power. So I'm going to look at my steps and start with the number 1. So I'm going to write the number 1 down. Now I'm putting a decimal point after the 1 because for a whole number, that's where it goes, after the number. I'm going to jump that decimal point to the left because this number is negative. So if I see negative 2, the negative sign means I'm going to jump the decimal point to the left. The value, or the absolute value of the exponent, 2, tells me how many jumps to make. So the number of jumps is equal to the value of the exponent. So 10 to the negative second power means write down a 1, and then take the decimal point and jump it 2 spaces left. All right, so I did that. So now I have to fill in the empty space I made here with a 0, which I'm going to do. And I'm going to make sure my point, since I jumped it, moves to its new home, or its new location. Same thing with the second problem. I'm going to start by writing down a 1 with this decimal point. I'm going to look at the exponent. Negative sign means move it left. 5 means move it left 5 spaces, so I'm going to write down my 5 jumps. And I have 1, 2, 3, it looks like 4 spaces to fill in with zeros. And I'm going to make sure my decimal point jumps to its new home at the end of my jumps. So those are your answers. So I'm going to clean them up. I'm going to put a 0 in front of the point to clean them up. I'm going to get rid of the jumps, the little marks I made on here. And 10 to the negative second power is 1 100th. 10 to the negative fifth power is 1 100,000. All right? And that's how you do this. So let's take a look at some other ones and show how this works for positive exponents as well. And then I'll let you do some practice. So you can see here, I kind of jumped ahead with my steps. We solved these 2 problems earlier, so we already know what the answers are. But if I follow my steps, if I start by writing a 1 down, and I look at the point, and I'm going to move this point 2 spaces, because the exponent's 2. Since it's positive 2, I'm going to move it to the right. So I'm jumping 2 spaces. Down here, start with a 1 with my decimal point. Jump 5 spaces because the exponent's 5, and since it's positive, it jumps right. Fill in my zeros. I'm going to clean it up by getting rid of the marks and the decimal points, and those are my answers. So 10 to the second power is 100. 10 to the fifth power is 100,000. All right? So hit pause, take a second to try these by doing the jumps, and then you can unpause and see how you did. All right, there are your answers. So for question 1, negative 4 means put the point after the 1 and jump it 4 spaces left. Positive 6 means put a point after the 1, kind of where this comma would be, and jump 6 spaces right because it's positive. And remember, you're filling in all your empty jumps with zeros. Negative 11 means put a point after the 1 and jump it 11 spaces left. Negative means left, 11 means 11 left. So you got your point all the way here. And then 10 to the first power means you start with a 1 and you jump it 1 space to the right because it was positive 1. All right? So here's a chart you can use to take a look at and reference as you solve some problems if you're having trouble. One thing I want you to notice is that look at the relationship that some of these have. 10 to the first power is 10. 10 to the negative first power is 1/10. 10 to the second power is 100. 10 to the negative second power is 1 100th. And if you look at how it's solved, 10 to the second power is 10 times 10. 10 to the negative second power is just 1/10 times 1/10. So you're still doing 10 times 10, but you're putting it as the denominator of the fraction, so it becomes 1 100th instead. So it's a neat little relationship you can use to help maybe remember, like 10 to the negative fourth power is going to be said almost the same as 10 to the fourth power. 10 to the fourth power is 10,000. 10 to the negative fourth power is 1/10,000th. Okay? So now we're going to go backwards. We're going to start with standard form and make it into a power of 10 in exponential form. And so we're basically going to do our jumps, doing our steps in reverse. So here's my problem. And what I'm going to do first is start at the decimal point. And I'm going to jump, but I'm going to jump until I jump over the 1 and put my point at the to the right of the 1. So kind of like where we started with the other method. We're doing it all backwards, basically. All right? So if I jump all the way to the right of the 1, that's going to be 1, 2, 3, 4, 5, looks like 6 jumps. All right, so here's what I'm going to write as my answer. I'm going to have a base of 10. We're doing powers of 10, so the base is going to be 10. The exponent is going to be a 6. We just need to decide whether it's positive 6 or negative 6. So look at the number we started with. Is this number a really large number or a really small number? It's a really small number. So if your number that you start out with is less than 1, if it's a small number like that, the exponent's going to be negative. All right, so we start with a base 10. We did 6 jumps, and that 6 is negative because we started with a smaller number than 1. All right, let's take a look at example 2. This time we're doing 10 million. So I already put my point in at the very end of the number because when we have a large number like this, there's no decimal point written to begin with, so we have to write one at the end of the number. All right, so I wrote my decimal point at the end of the number. Now I'm going to jump until I get right after the 1, like I did with the last problem. So when I do that, I create 1, 2, 3, 4, 5, 6, it looks like 7 jumps. 1, 2, 3, 4, 5, 6, 7 jumps. Yep. So I do my 7 jumps. So when I write out my answer, I'm going to have a base 10, and the number of jumps is the value of the exponent. So it's going to be 10 either to the 7th power or to the negative 7th power. Since I'm starting out with a number greater than 1, a large number, it's going to be positive 7, so 10 to the 7th power. Okay, so try that out. See how you do, hit pause, and then when you're done, you can take a look at the answers to see how you did. Okay, so you can take a look here at the answers. So for the first problem, I start at the end, since there's no decimal point to start with. I jump in 3, 6, 9, 10, 11 spaces to get right after the 1 where my cursor is. Since the number is a large number, the answer is a positive exponent, so it's 10 to the 11th power. For the second one, I have my decimal point to start with. I'm going to jump it to the spot where it's right after the 1. That will be 1, 2, 3, 4 jumps. Since the number is smaller than 1 when I started, it's 10 to the negative 4th. Okay, this one here, I have 3 jumps to go from the end of the number to where the comma is basically, because that's right after the 1, and it's a larger number than 1, so it's 10 to the 3rd power. And the last one, I only have to jump 1 space to get to the right of the 1, so it's going to be 10 to the 1st power, but it's negative 1 because this number here is less than 1. All right, so that was your lesson about powers of 10. So you can rewatch the video if you need to. Make sure you do your practice with your homework, and I will see you next time.